Okay, this video is about computing area using definite integrals. So one of the things that we can do with a definite integral is compute the area under a curve, although it's not exactly that. Sometimes it counts the area as negative if something is, say, under the x-axis, if your function is under the x-axis. And so we're going to work this example from the book. This is section 7.3, problem number 30. And I chose this example because it's somewhat difficult, I think. And so why is it difficult? First of all, what is the problem? We want to find the area bounded by the function x cubed minus x and the x-axis. And so normally they would give you your limits of integration, like they would say the area under this curve between x equals 0 and x equals 1, for example. But that's not the case here. So what do they mean by this? And the best way to see what they mean by this is to draw a graph. And you can use your graphing utility, like your graphing calculator, or something like that. Or you can factor this expression into x times x plus 1 times x minus 1, and this makes it apparent what the zeros are. And then maybe you could take the derivative to see where it's increasing and decreasing, for example, or where it's concave up or concave down. But really, this very rough sketch is going to be good enough for our purposes. And it makes it more obvious what they mean by this. So what regions are in between the x-axis and this function? Well, I'll shade them in right here. So there's this part and this part. Now, how do we find this? Well, normally you might think mistakenly to integrate this function from -1 to 1, but what happens when we do that? Let's just see what happens if I integrate from -1 to 1 of x cubed minus x dx. Oops. Well, so what do I do first? I find the antiderivative and evaluate at the endpoints. So what is the antiderivative? By the power rule, I get that this is 3 plus 1 is 4, so I get x to the 4 over 4 and minus x squared over 2. And I want to evaluate this at -1 and 1. And so what do I get? Well, if I evaluate this expression at 1 to the 4 over 4 is just 1 over 4, minus 1 to the 2 over 2, which is 1/2, and then I subtract the function evaluated at the other endpoint. Well, -1 to the 4 is +1 over 4, and I want this in parentheses. And -1 to the 2 is +1 over 2, and as you can see, this equals 0. And so how could that be right? Well, it's not correct, and the reason is that we are counting this area as negative. That's the way that this definite integral accounts for this area below the x-axis. It is negative, and so we're getting this is canceling this out. So what do we want to do? What we want to do is, well, why don't we take the part that's positive and calculate that area? And the part that's positive is from x equals -1 to 0. So this is not correct. And so I'll start by integrating from -1 to 0 of my function x cubed minus x. Okay. And of course we get the same antiderivative in this case. We get x to the 4 over 4 minus x to the 2 over 2. But my limits of integration are different. So I'm evaluating at -1 and 0. And I evaluate the top endpoint first, and it looks pretty easy to see that I'm going to get 0 for that expression. So when I evaluate that function, my antiderivative, at 0, I just get 0. And then I subtract when I evaluate this function evaluated at -1, which is actually just right here, because we already did that. So I get -1/4 minus 1/2, and I have to be careful that I'm subtracting this quantity in parentheses. Indeed, because I will get minus 1/4 minus 1/2 is minus 1/2, or sorry, minus 1/4. And so I get positive 1/4, which makes sense. I should have gotten a positive number for this, because this number 1/4 should be this area right here in between -1 and 0, and this graph and the x-axis. Okay, so now I just need to get this part, and the way I can compensate for it being negative, well, if I integrate from 0 to 1, it's going to count this in this area as negative, so I'll just take the negative of that. So minus the integral from 0 to 1 of x cubed minus x. And this is much like what we just did. Of course, I get the same antiderivative. It's the same function. So I get x to the 4th over 4 minus x to the 2 over 2. And what endpoints am I evaluating at? I'm evaluating at 0 and 1. So if I evaluate at 1, it's somewhat easy to see that I get 1/4 minus 1/2. And when I evaluate at 0, I get 0, just as before. And I even forgot already to put my minus sign here, so I should have a minus sign here and a minus sign here with brackets around this whole expression. And inside here I get 1/4 minus 1/2 as before, so I get negative 1/4, but I take the negative of that, and I get positive 1/4 again. Okay, so I found that this area here is 1/4, and I found that this area here is 1/4. The actual area is 1/4. The integral is negative 1/4, but that makes this actual area 1/4. And so my total area is the sum of these two, and I get 1/2 as my final answer. And that concludes this video.